Hi, second year students, especially new course for Federal Board, Exercise 4.4, application of calculus. Without wasting time, let's jump down to question number one. Look at the application and simplicity of the application. They do, they work wonders in applications type of mathematics. Everybody frequently asks, what are the applications of mathematics? I say nothing is free from mathematics. Nothing is independent from mathematics. Let's see its ample proof. Question number one. If at present the population of a city is 20 million, if at present the population of a city is 20 million, initially when we are starting the calculation, taking the base year 0, the present, the population is 20, and after 4 years it is expected to be 25 millions. In the span of 4 years, population increases 5 million from 20 to 25. What would be the population of that city after 12 years? We are interested in the calculation of the population after 12 years. Initial population of 20 million on the outset at the commencement of our problem, and after 4 years it is expected that population is approximately 25 million. There is increase of 5 million in that within the short interval of time 4 years. What would be the population of the city after 12 years? In your textbook they have written, Malthus has given this idea or concept. Malthus states that population increases geometrically. Population increases geometrically, exponentially, where r is greater than 1. Where r is greater than 1. Let's see and find out. Increase. Increase or decrease, both are dubbed in a single concept of differentiation. P for population, rate of change of population, increase or decrease, is directly proportional to the population present. Look at this. Number one, step number one, make or break. Wonderful concept. Rate of change. Rate of change encompasses two things: increase or decrease. Increase or decrease. Increase or decrease. Rate of change. The rate of change of population with respect time is proportional to the population present. Population present. Initially, population present. Now we are familiar from our tiny concept of physics, but wonderful second law of Newton. Force is directly proportional to acceleration. When we remove proportional, we introduce a constant of proportionality. In that case, it is m. In that case, it is m. In the same token, we introduce a constant and determine the constant by utilizing the given conditions. dp over dt is equal to k times p. K times p. If it is the question of increase, k obviously greater than 0. If it is question of decrease, k is less than 0. That is the technicality to be noted down, to be narrowed down in order to apply the concept here. F is directly proportional to AV. In the same token, population, rate of change of population with respect to time is directly proportional to its population present. Whether population increases or decreases, it depends upon k. Obviously, in that case, population is increasing, so our k is to be positive one, not negative one. K is to be positive one. Here, it is the case. Now, it is simple question of separable differential equation. Separable differential equation. We need neither dp in denominator nor dt. dp is already present in numerator. Let's move dt towards right hand side in order to convert that differential in, write this differential in numerator, k times p dt. Now it is a separable differential equation. Towards p terms towards dp and t terms towards dt. We have dp over p, that says k times dt. Integrating both sides with respect to our independent variables. K is the constant to be determined, 1 times dt. Integrate 1 over p is the famous case of ln p. We are familiar. K times t and another integration constant c. Integration constant c. To make life simple, get rid of this ln. We know that inverse of ln x is e power x. Inverse of ln x is e power x, and inverse of e power x is ln x. These are inverse of each other. These are inverse of each other. To get rid of ln, take e as a base. E times ln p, e times kt plus c, k times c plus c cancelled out. We have p is equal to e raised kt plus c. Making life more simple, this can be written as e raised kt times e raised c. E raised c is a pure constant. I can write this one as e raised kt, e raised c, another constant c1, say suppose c1. So that is the solution of this differential equation. Now we utilize the conditions that given to us at the outset. Population is 20 million. Initially means time is 0. We have c value of c1, that's 20. Then after 4 years, population is 25. Population is 25. We put t is equal to 4 and determine the value of k. Let's see and find out how. I hope you have galloped, you have swallowed this concept, you have understand this concept. Simply, rate of population present is directly proportional to the population present. It depends upon k. If k is positive, then population is definitely increasing, otherwise decreasing. But in our case, it is increasing. No doubt, population is increasing. It is a havoc for third world. Let's see. P is equal to E times kt times c1. Okay, initially at t is equal to 0, when we are starting this survey or whatever the case is, at the commencement of our population is 20. Population is 20 million. At the start means put t is equal to 0. That's our initial condition. That to be utilized in order to get to the values of k and c. 1. Any non-zero quantity raised to 0 power is equal to 1. So 20 is the value of C1. 20 is the value of C1. Utilize here. We have P is equal to E times KT. C1 is 20. Means I can write P is 20 times E raised KT. E raised KT. We have utilized the condition 1. Initially, our population is 20 million. Initially. When we are starting our survey or whatever the case is, initially population is 20 million. In the time interval of 4 years, after 4 years, population is 25 million. 25 millions means now P is 25. 20 E raised k times t is 4. After 4 years, 4. 25, shift 20 here. It is e raised 4k. It will become 5 over 4. 5 over 4. So we have e raised 4 times k is equal to 5 over 4. To get rid of e, introducing ln both sides, ln as a base. To remove e, take ln as a base. To remove ln, take e as a base. It is e, take ln as a base. Ln e raised 4k. It's our ln 5 over 4. ln e cancelled out or make this 4k coefficient. ln e is equal to 1. We are familiar ln 5 over. A tiny calculator that I have arranged for myself. ln e is 1. 4k times 1. What about ln 5 upon 4? ln 5 divided by 4. Let me check by introducing brackets. ln 5 divided by 4 bracket over. Now its answer is different in that case. 0.223. 4k is equal to 0.223. Let me confirm this. 5 divided by 4. It's mine 1.25. Now ln 1.25. That must be authentic. 0.223. We are cool. 4 times k. So k is equal to 0.223 divided by 4. Divided by 4. We have k is equal to 0.557. 557. Let me round off this one. 78 is there. I am writing 0.58. Okay, let me write 5. 0.5578. That's mean value of k. That's mean value of k. Okay, cool. Now we have determined the value of k. We are about to launch the final portion of the question. We find the required population after how many years? I think 12 years. Let's see. We have now p is equal to e raised kt. We have already determined it's 20. Now k is 0. P is equal to 20 times e raised k means 0.55780. 780. That's the value of C1. Constant we have determined, that's the value of K. Cool. Now just put the value of T. After 12 years, what is the population? Let's see and find out. P is equal to 20. E raised 0.557. T is 12. T is 12. I haven't removed this figure. Look at this. I have kept it in it. Just multiply by 12. Multiplying 12. I have P is equal to 20 times e raised 0.6694. 0.6694. Let me calculate this. Shift to get e 0.6694. It is 1.95. P is equal 20 times 1.20 times 1.9530, whatever the case is, just multiply by 20. So our population is 39.06 millions approximately in that case. 39.06 millions is our population after 12 years. After 12 years. That is a simple application of differential equations. Rate of change of population means dp, change in population with respect to time, is directly proportional to the population present. It is a constant of proportionality. I have given you the idea. F is directly proportional to A. We introduce a constant. In the same token, we take a constant of proportionality, that is key. That's Kp, K times P. If our K is positive, our rate of change is increase. If K is less than 0, it's case of decrease. In that case, K is greater than 0 because it is a question of population. Population is constantly increasing, no doubt. We have determined after utilizing this, put initial condition at t is equal to 0. At t is equal to 0, I have found out the value of C1. Put here again. Then we have given another condition. After some 4 years, our population is 25 years. Population I have 25 years. After 4 years, I have write down, instead of I have plugged in the value of T4. Then I am in a position to find the value of K. When I have now both constants C1 and K. Look, value of C1 is 20. Value of K is 0.557 raised T. Now we are fit. It is the equation of the population increased regarding this question, according to these conditions, according to this condition. Now we are asked to find the what is population after 12 years. Simply introduce instead of simply introduce 12 instead of t, 0.557 times t. That's our answer in that case. Almost 39.06 million years. 39 million years, one can say, is the population after 12 years. Initially we have given population 20. After 4 years there's an increase of 5 millions. Then we are asked to find what is the population after 12 years. We have given two conditions. Look at this. 20 million initially. 20 million initially. T is equal to 0. Population is 20 million. Okay. That's the one condition we have determined constant. Another condition after 4 years. Another condition after 4 years, our population is 25. Utilizing this, we have managed the value of K. These two constants are involved in that equation. That equation C1 and K we have determined because of owing to thanks to these two conditions that has been given to us. We have K, we have C1. Now we are all set. That's our equation of the population increase according to this question. It is asked after 12 years put T is equal to F. After 15 years insert T is equal to 15. After T is equal to 2 decades, 20 years, and whatever the case is, it is our solution in that case. Moving towards the next question. Moving towards next question. Uh, Thanks to Newton Bohm, Aisha was preparing a pizza in a baking oven. She observed that, oh, cool, cool. I think we haven't made this equation correct. First, there was a 150, then after some time, pass me the book. Let me manage this question because we must have two conditions in order to determine the value of constants. Okay, that is the cool. 150, 150, and after 4 minutes, 4 minutes, and after 4 minutes after removing from the oven, the temperature of the pizza was 90. Initially 150, 150 degrees Celsius. After 4 minutes, 90 degrees Celsius. After 4 minutes. After 4 minutes. Our mistake in writing question. I hope you manage it. Okay, without wasting time, let's solve this one as well. Now, T stands for temperature towards dt, capital dt. dt divided by T minus T naught is equal to K times dt. K times dt. Integrating both sides, it is a separable differential equation. dt over T minus T naught is equal to K times dt. Take care, small t stands for time, this T stands for time, and capital T for temperature. Capital T for temperature, and we have to compare every temperature to the room temperature or ground level temperature. Room temperature. It is RT naught. It's RT naught. There is a famous case of this one. It's T naught. It is given to us. It is always constant. It is this T is our variable. 1 over x, 1 over x, 1 over t. Its integration is ln T minus T naught. Keeping T naught as a constant. It is equal to K times T plus C. Some solvers introduce E to get rid of ln. They solve then. We can solve in ln form as well as without ln form. I am trying first with ln form. Okay. Now we have given temperature. Our initial temperature is 150. When the pizza comes out of the baking oven, its temperature was 150, and our room temperature is 20. So we have ln 150. Comparison with the base state, ground state, room temperature, that's 20. It's equal to KT initially. 150 initially at the start when the pizza comes out of the bacon, 150. At the start means initially time is 0 plus C. So we have ln 130 is equal to C. That's our value of the C. Let me use some calculator. ln 130. I have C is equal to 4.8675. Cool. Now replace this C here C. So we have ln T minus T naught is equal to K times T. C is 4.8675. If you want to write T naught constantly 20, in order not to make mistake, it's 20 constant fixed, ground state or room temperature. We have determined the value of C. Now we are interested to determine the value of K. To determine the value of K, we have given another initial condition. After 4 minutes, the temperature was 90 degrees centigrade. T4 time is after 4 minutes and temperature is 90 degrees centigrade. T90 and small t after 4 minutes. Right here 4 instead of small t, and capital T means temperature, that is our 90 degrees Celsius in that case. Cool. Let me move forward. Let me find the value of K, another constant. Then we jump to the conclusion what we have to do. Okay, here I have ln t minus 20 kt. We have determined the value of C, that's 4.8675. Now after 4 minutes, after 4 minutes, after 4 minutes, the temperature of the pizza was noted to be 90 degrees Celsius. Utilize this to get K. I have ln T means 90 initial we have done. It's our room temperature, that's 20. K after 4 minutes T4. C we have already determined 4.8675. 90 minus 20, that's ln 70 is equal to 4K plus 4.8675. 4.8675. I have written already. ln 70. ln 70. I have 4.248. 498 is enough. 4K plus 4.8675. Shift 4.8665 here to find K. We are solving for K. 4.24849 minus 4.8675 is equal to 4K minus 4.8675 is equal to negative 0.619004, whatever the case is. Shift 4 here, dividing by 4, we have negative 0.619004 divided by 4 is equal to K. After division we have negative 0.15475. It's enough, that's the value of K, now we are done. Introduce value of K here. We have already managed the value of C. Then now we are asked to find that when the temperature is 40 degrees Celsius. When temperature is 40 degrees Celsius, we utilize instead of this temperature T 40 and solve for this T It seems to be, it's just like this. Let me write the value of K here. Okay. What is the value of K? Sorry. I have almost done a mistake by rubbing this. Wait. Let me put this value of K here, and we are finally in a position to determine whether the temperature at a specific time or a specific time at the specific temperature T is equal to minus 20 or K is negative 0.15475 times T plus 4.8675. Have you noticed, have you taken care of this negative? This negative sign show that our rate of change decreases. Look at this. In that case, the temperature is decreasing. In first problem, population is increasing. That's why value of K is positive. If it is a question of increase, K is positive. If it's question of decrease, K or constant decreases. It's negative means decrease. Okay, cool. We are done. We are asked how long means time. We are asked to find when the temperature is 40. Temperature is 40, we have to find the temperature. Temperature is 40, our initial or ground temperature, room temperature is 20, negative 0.15475 times T plus 4.8675. Let me use a tiny calculator. ln 20, it is same. ln 20 is 2.9957, 3 is there, minus 0.15475 plus 4.8675. Cool. Shift this quantity here from positive to negative, solving for t. 2.9957 minus 4.8675. It's equal to negative 0.15475 times t. Let me read this. We have done ln 2.99 minus 4.8675. 4.8675. It's equal to negative 1.87176 whatever the case is, negative 0.15475 t. Minus cancelled. Shift this quantity here for a multiplication of division. 1.8716 divided by 0.1547 is equal to t. Dividing by 0.15475. It's equal to t is equal to 12.095 minutes approximately.